And thank you for coming here. We are very, very happy to be here at Day on the Beach. And we are going to talk to you about how technology can help us enjoy our vacations even more. Okay.
First of all, happy Geek Pride Day. I brought my towel. So, okay, we are Isa. I'm Isa. Cabezas. She's Juliet. Okay, as Luis said, we are working in Microsoft. She's from Sevilla. She's a technical evangelist in Microsoft. She's from Sevilla. It's because of that I put a drawing of the Giralda in Sevilla, and I'm from Granada. So I put an icon of the Alhambra, the important one, the pier, of course.
Okay, so we want to know how much technology you use here in this room, okay? So how many of you have about 5 or more devices connected to your home network? I do.
5?
10? 20? 30? 40? Okay.
Really?
Okay, well, I went into my router the other day and I had 48, I think it was. So, but after the talk, you'll understand why. Okay.
Okay. When I was a child, the technology was the PC we had in the study room, and if we needed it, we had to go there and use the technology. Nowadays, technology is everywhere. We have it at work, at home, in our car. We can wear it like our smart watch. IoT means that connect everything that you can to internet. Like we can connect our fridge, our washing machine. We can connect our lights at home. We can connect our thermomix, yeah, thermostat, to our pets, our phone, of course. We can connect everything. Our toilet, really? Okay, we are using technology to build a better world, more comfortable, more safer, and technology should be discreet and available to everyone. It's getting smaller every day, almost invisible.
Yeah. So, how can technology help us with our vacations, which is what we came here to talk about, right? Well, if we go to the beach, we want to go to the beach with friends. First thing we need to do is take the car and drive to the beach, especially if you live in Spain, right? And if you bought a car lately, you'll see it has a lot of features, new features that help us make that drive, easier, better, safer. One, for example, is the head-up display. It's like a small screen that appears on top of the, how's that called? Well, where we're looking, right onto the road. And information is projected directly onto that small screen. We can see the speed that we have. We can see the directions that we have to take. We can also see traffic warnings if we're, speeding or things like that. So it's quite useful because you don't have to move your, you don't have to move your eyes from where you want to go. It's safer, right? Another cool thing that cars have now is speech recognition systems. So, maybe we're in a traffic jam and we're going to be late. We can tell a car, please call my friends, and then you tell them, hey, I'm going to be late, wait for me. All right, so that's...
Save an espeto for me. I don't
yeah,
know how to
save an espeto for me.
Save an espeto.
I'm hungry. Okay, so, all right, so we get to the beach, and we're happy, we're enjoying, but what happens to our pets at home? What happens to our plants? Who is taking care of them? Well, we can use technology for this as well. For example, we can build a watering system, an automatic watering system for our plants. We can also build an automatic feeder for our pets so that, when we get back, they'll be healthy, they'll be happy, they won't hate us.
If you add a cat in your slides, it improves a lot.
Yeah, the cat. Well, the cat is happy. So, all right, we have everything under control except one thing. If we're on vacation, burglars might want to enter our house, and that's no fun, right? So we can use technology there as well. We can use security cameras. We can build our security cameras. We could use a Raspberry Pi and a small camera sensor, connect to it, and we can check from a mobile phone what is going on inside our house. We can also use door sensors, which will tell us, if a door is open, if someone has entered our house. We can use mobile, movement sensors. If something is moving inside our house, we can get a notification. So we have, we know everything that's going on. And also, if we can control things like lights remotely, we can turn them on, off. So maybe the burglars will think that we're not on vacation. They'll think that we're still there, and they might think twice before entering our house, right?
Okay, so we started to work in some kind of solution for this problem that we had. At the beginning, we looked for a commercial product for installing it at our home. We found some of them, but we didn't really like any of them because they have remote control that, of course, I have a lot of light bulbs at home, and I had like 20 remote controls or 20 applications in my phone for manage my lights, my lamps. It's not, we didn't find anything we can automate on everything, only one application. Well, in fact, we did find it. We did find one solution that we thought it was really good. Maybe you know Philips Hue? Yeah, yes, probably yes. Okay, they have only one remote control to manage all the bulbs. It acts like a bridge, and you can manage all of them. And it has color, so it's really cool. But the main issue we found is like it cost about 160 euros, the package of 3 light bulbs and the control. So, okay, I have like 30 light bulbs at home, so it's a little bit expensive, and of course we already spent all our money on holidays, so we didn't have it. So let's find another solution, cheaper, if it's possible.
Yeah.
Okay.
Yeah, so we have no money. So we want to do something else. We already have light bulbs in our house, so why buy new ones, right? Maybe it would be a good idea to make those light bulbs more intelligent. So that's when we found out about the ESP8266. This is that you can see here, there are many different versions, but they have several things in common. One is that it has it's a microchip, okay? One is that it has a microcontroller, so we can deploy our code directly. We don't need an Arduino or anything external. And the other thing is that it has an antenna, a Wi-Fi antenna, so we can connect remotely to it. We don't have to be connecting every time we want to change something, okay? Good things about the ESP8266. Well, first of all, it's tiny. It's very, very small. It's not all of this. It's just this tiny part right here. Probably in the back, you can't even see it, okay? But here's a photo. So why is that good? Well, if we have a lot of light bulbs at home and we want to use one of these for each of them, we probably want to hide them, right? We don't want something big, everywhere inside our house. So we can hide that behind the light switch, for example, or in the ceiling. We can make a small box to, hide it a bit. So that's pretty good. The other good thing is that it's very cheap. It costs €1.50. Okay, you can't ask for more, €1.50. And just in case you don't believe us, it can't be that cheap, we took a screenshot of an online store where you can buy it for €1.50. The only thing is that it does take like a month or even more to get, at least here in Spain. But hey, for €1.50, we can be patient, right? It'll be okay. So, okay, we have our light bulbs, we have our ESP. We still need something else. That's when we need a relay. A relay will open the circuit or close it, depending on whether we want to turn on the lights or turn them off.
Sorry, okay. Okay, a relay is an electrically operated switch composed of an armature, a spring, and a set of electrical contacts. It's like this, you can see it, okay. This.
Yeah, there's a photo there. In the slide it's very big, it's also very small, okay? And it's still very cheap. For €1 or probably even less, you can buy a relay. All right, so we have the light bulb, we have the ESP, we have a relay. Here we've connected it just with a few cables for testing, okay? Here you can see that this is actually bigger than an ESP. There are certain things that are node MCUs. They're like development kits, which have an ESP. They also have some pins, some general purpose input-output pins. It has a micro USB, so you can connect, or mini, no, micro, I think, USB, so you can connect it directly. It has other things. And this can be very, very useful when you're developing, when you're testing. And then once your code is perfect, everything's working fine, then you can just use an ESP instead of a node MCU and use that in your house, all right? Okay, but we're still missing something, because in our house we have normally about 220 volts. We can't just connect this directly in our house, right? We need a transformer, something else. Well, that's when we found out about the SON-OFF. The SON-OFF is an intelligent switch, and it has, and it has an ESP8266, it has a relay, it has a transformer, and some other things. But it's all, packed in this small device. It's still small, and it's still cheap. It's still €4, so we're still saving money. So, what happens if we open the SON-OFF? It's what Isa has here. It's what we have in the slide. We can see, as we said, the ESP right here with its antenna. We can see a relay, the transformer. It has a button. We'll see the use of that button a little bit later. It has a LED and the input and output. All right. One question which we often get is how much power consumption this has on standby, because if you have it, even if the light is off, the SON-OFF is still, we say, working, right? If you check the specifications in the SON-OFF webpage, you'll see it says it's 0.5 watts. If you turn a SON-OFF on, if you get a SON-OFF and you measure it yourself, you'll see it's more like 0.6 watts. And if the relay is turned on, then it gets up to 0.9, okay? It's still pretty much comparable to what, for example, a TV uses on standby. It might actually be a bit less. So it's still, it's not high. It's pretty good, right? So, about the SON-OFF. There are many different types. There are many different versions. If we just want to turn our lights on and off, we can use the basic one. It's also the cheapest one, the one we were talking about all this time. But just so you know, there are other ones, okay? There's one where you can use radio frequency. There's one prepared to connect a humidity and temperature sensor directly. There's also a dual one that can be useful. For example, imagine you have window shades or window blinds. You need them to go up, you need them to go down, so you would need two relays. You can't just use one. For that, we could use a SON-OFF dual because it has, the two relays. They also sell a touch light screen. It's like a button. We'll talk about that a bit more later. You don't need this one, but just so you know, they sell it as well. But for what we want, we can just use the basic one for now, okay? So, we get our light bulb. We connect the SON-OFF. What do we do next? First, we can download an app. It's developed or published by the company that makes the SON-OFF. It's called IoT. And if we check the interface right here, we can see we can turn the light on, or the SON-OFF on, off. We can add a timer and a few more things, but not much more. It's not very complete. We can do better than that, right? So we started investigating, and we saw that there's a lot of firmware out there made by the community, so it's open source, you can use it, you can change it. And there's one in particular that we liked especially. It was Tasmota. It's called Tasmota. It has many features. For example, it's ready for MQTT, for over-the-air updates, Wi-Fi manager. It has a lot of things. You can actually comment the ones that you don't want to use, but they're ready for there. You don't have to code anything extra. You can just use this firmware.
Okay, so let's start to work with Tasmota. The first thing we need is download the code. You can go to the GitHub of SON-OFF Tasmota and download it, or as a zip, or clone it, or whatever. Then open the SON-OFF. Okay, I wanted to move. So you have to open the SON-OFF. It has like 4 screws, so you have to unscrew it because if not, you are not going to open the Tasmota. This is the easy part. Yeah. And so now, okay, I have a schema like that. You have like 4 pins, and you have to connect the SON-OFF to the PC. For that, you need an FTDI, that is the red, can you, yeah. this adapter, that is just adapter from TTL to USB for your PC, to your USB port. And so you have in your Sonoff like 4 pins that is just over the physical button. Can you? Yeah.
It's right here. Okay. Actually, there's 5.
The physical button of the Sonoff is here, and you have the 4 first pin here, and you have to connect these pins to the FTDI, and it's very easy because you only have to put the Sonoff pin of 3 volts with the FTD pin 3 volts and ground with ground, but be careful with the other 2 in the middle because we have an input pin, the RX, and an output pin, the TX, and you have to cross them. So be careful with that, but it's really easy. You can use this slide like an schema because you have the pins there, and taking the physical button as a reference is really easy. So, okay, I know this is an awful slide, but it's just a cheat sheet. After that, you have to open the sonoff.ino that you download it from the repo of Taxmota, and open it with the IDE that you prefer, like Arduino IDE or maybe Visual Studio Code, of course, if you prefer, and just set this configuration in your IDE, your favorite IDE. Okay, don't forget that we are working with an ESP8260C board, and just configure like that. Okay, and now the deployment. Put the firmware inside the Taxmota. So, okay, the first is be careful with the connection between the FTDI and the Sonoff because sometimes you can solder it, so be careful with that. Connect them, and maybe you need a helper, another person to taking care of that. And after that, okay, push the button, the physical button of the Sonoff, then plug into the USB in the PC, and then release the physical button. This is you put the Sonoff like a flash mode, and then use the button, the upload button of the Arduino IDE, that is this arrow here, click. And then when the deployment finishes, you have a small web server inside the Sonoff. Taxmota create a small web server, and you can go to this URL, Sonoff, and see the main page. So we have here a picture of Juliet, really taking care of our connection. And okay, let's see if it works. We have our Sonoff here. It's connected, it's plugged here. Our Sonoff, and with a light bulb. Can you? Yeah. So it's connected to the Wi-Fi, both.
This is
the
the
Sonoff
Taxmota user interface.
and this is the main page of Taxmota. Yeah. So if the Wi-Fi works, yeah. Please, a live demo. Thank you. Okay, just the last thing is think about your circuit at home. You have your lamps, your lights, and your switch on the wall. And if you put your Sonoff in the middle, and your switch have to stay like open if your lights are off and close if your lights are on. If you put your Sonoff in the middle and you open the circuit, what happens? That the Sonoff doesn't work, of course. So we have to replace the switch. Well, we should replace the switch on the wall, and we have to put a button. It's the kind of button that we have in our doorbell that doesn't open the circuit. So you should connect the physical button, this button, to the Sonoff, You can connect it to the GPU 14. Sometimes people say that, okay, it works. But personally, with our experience, we recommend you that connect to the physical button in the Sonoff. Why? Because you have some commands in your Sonoff, like if you push the button 7 times, you can restart the Sonoff. So it's very useful if you connect to the physical button of the Sonoff, and press 7 times your switch on the wall for restart it if it needed.
Okay, so.
If you have children, maybe it's not a good idea.
Yeah, if you have kids, it might be
that
resetting the sun off all the time, but okay. Well, okay. The thing is, now we can control our lights, but we probably have a lot of lights at home, we have a lot of devices, and we might want to control them remotely as well, right? Wouldn't it be great to have like a home central, a place where we can control all of those devices in one same, we could say page or window or place? For that, we have several options. We can use, for example, domotics, or we can use Home Assistant. There are other ones as well. The good thing about these is they are open source platforms. They're ready to be installed, for example, on a Raspberry Pi. So if we have a Raspberry Pi, we can start, using these right away. For example, Home Assistant, well, we have a Raspberry Pi, we install the operating system, we install Home Assistant, we configure it, we manage it. Now we also have the option to use HAS-IO, which is a combination of Home Assistant and some other tools. It's all packed in an image so that we can deploy it directly on the Raspberry Pi, and we don't have to worry about, a lot of other things, management, configuration, etc. Okay, but we have our Sonoff. We have our Home Assistant, for example. How do they communicate? What is going on in between? Or how do we make it work, right? For this, first we have to talk about MQTT. MQTT is a lightweight messaging protocol, and it works using the publisher subscriber model, okay? So in this example, we have a temperature sensor, all right? When it reaches a certain temperature, for example here 23 Celsius, it will send a message, it will publish a message to the MQTT broker, and we have a series of devices or clients which are subscribed to that temperature topic, all right? When that message is received to the broker, those devices receive that temperature message, and they decide what to do. If it's a mobile device, for example, it might give us a warning, show us a temperature. If it's an air conditioning machine, it might decide, well, it's getting hot in that house, so let's turn the air conditioning on, all right? So, we know how it communicates, but how do we make this real? How do we, specify in our Home Assistant? Well, we can do that through code. We just write some code in YAML. And, well, the good thing is, because there are so many people using this already, there are a lot of components which are already developed and ready for us to use with just a few lines of code, okay? We don't have to code the whole thing. So, for instance, for this, for what we see right below here, this is like a menu with just 2 lights, kitchen and living room with 2 switches. In code, we indicate that using the code on the left. We just say we have 2 switches, 1 living room, 1 kitchen, all right? And then we also need to specify, what are we going to do when we click on this switch? How do we publish those messages for the MQTT broker? That's what we do on the right, okay? That's a MQTT switch in Home Assistant. We just indicate command topic, which is the topic to which we will be publishing those messages to, okay, when we click on this switch, so it gets to the Sonoff, and then the Sonoff turns on the light. And state topic, that's the topic where we will be subscribing to read messages, because, we might have the light switch or the light button, someone might turn the light on, and we want to know that in this menu, in this interface as well. So if that happens, the switch will also turn on because it's subscribed to that topic, right? And okay, so we can control them remotely from our mobile phone, for example, with this, with these switches. But we can go one step further. Wouldn't it be cool if we can control our lights with our voice? Like if we enter the living room and we say, lights on, and they turn on, that's like even more lazy. We don't have to take our phone out or anything at all, right? So we also tested this voice controlling system, okay? There are many different devices. For example, there's this Amazon Echo that uses the Alexa, running out of hands.
The microphone, the presentation.
Yeah. Okay, so this is the Amazon Echo. It uses the Alexa service. There's also the Microsoft Invoke. It's more recent. The Google Home. There are many devices in the market, okay? So we just happen to have this one. So I tested it in my home, and I decided to turn the lights on with it. And here we have a video to show it.
Ask Home to turn the kitchen light on.
Kitchen light turn on.
Alexa, ask Home to turn the kitchen light off.
Kitchen light turned off.
Okay.
Okay, well, that was my kitchen.
That's risky demo. Yes. Okay.
Yeah, it was clean that day.
So, okay, we managed our lights at home. But what about our pets or our plants? Okay, last time I went on holiday, when I went back, I found my plants like this one that is dead. Okay, maybe you are
Very
not,
dead.
You are not an expert in gardening, but yes, it's really dead. So, and Juliet also has some kind of similar experience with her plants. So, okay, let's work in a project for the survival of our plants. And this is our project. We have our plants. Really, I don't know the name of these flowers in
Narcissus,
English. Narcissus?
I think.
Okay. So each plant has an ESP8266, that is the chip that we speak a lot, with a ground humidity sensor that is like this one.
I'll find it here, this one right here. Ah.
Sorry. There. Engine killed itself. Okay, this is the humidity sensor. We have it controlled with an ESP8266. Is everything connected to the internet? Okay, I have the name of, and one of the plants has a temperature sensor as well with our ESP, and everything is connected to our local network and sending data to the cloud. We are using this cloud, Azure cloud, because of course it's Microsoft Cloud. So we have a service here that when the humidity, the ground humidity is very low, it sends a message to our board that in this case is a Node MSU, but it could be a Raspberry Pi, an Arduino, an Edison, whatever. And this message opens the water pump that we have here through a relay. So we could have this, any kind of board. The only thing they need is, of course, be connected to internet, and an out pin connected to the relay that opens the water pump. Okay, the second version of our project, it has this water pump that I don't have this one. That is very small and cheap. It costs like 10 euros. But the cool thing is it can be powered by something of 12 volts, like external battery, like the one we have in our cell phone. So when we connect, okay, you can hear it. We don't need to plug it in the garden if you don't have plugs. The last improvement is to have a solar external battery, because we don't need to recharge at home in our electricity of our home. And if we have a lot of sun with high temperature and your plants needs a lot of water, you always have your solar external battery with enough power. So, but the first version of our water pump, it was this. Okay, do-it-yourself water pump with this small vase and an engine like the one that
I just threw it on the floor.
okay, you know this kind of engines, yeah? with a battery, and you do like a kind of meal inside, and you can do your even cheaper
Really
water
cheap?
pump. Yeah. And the pictures below, it's our circuit that is all the circuit that we have in our plants, in production, you know. So, you want to explain a little bit our services?
Yeah, because we have the humidity sensor, it's sending information to the cloud. But what is going on in the cloud? Well, humidity sensor sends, is connected to the ESP, it sends a message with a humidity value, right? The IoT hub receives that. What is the IoT hub? It's a message hub which allows us to communicate, to have, it's a, it's a message hub that we can use to have communication in both ways between our IoT devices and our applications, okay? Really useful. So we want to have like a graphic or to see the progress of humidity every day, every week, every month. It'd be great to have like a graph showing that, right? So what we do is we have Azure Stream Analytics, which allows us to analyze really large amounts of data coming from our IoT devices. So it gets those messages about the humidity values, and we can use those messages or that information to show a graph, to show a report, for example, in Power BI, okay? And then we can see how humidity goes up, goes down, and we can do different analysis based on that information. At the same time, what we have is an Azure function. Azure Functions is a serverless service that we can use to run normally smallish code, okay? And the good thing is we don't have to worry about virtual machines, about anything else. We just have to worry about our code. In our case, that code is really, really simple. It basically checks that humidity value. If it's above a certain value, then it says, you don't have to do anything. The water has water, it's happy, no problem. If it's lower than that value, then what it will do is it will send a message back to the IoT hub saying, this plant needs water. Then the IoT hub sends a message to the ESP, which, is connected to a relay, which is connected to the water pump, opens the water pump, and our plant is happy and has water again. So that's what happens in the cloud, basically.
Our plant. Okay, we have, I don't know if, okay. It's very important, the sound in this video, because it's not, okay.
Yeah, this is one plant of ours.
Oh, yes, okay. The sound of this video, because, okay, you have our graph with the blue line is the temperature in Madrid. The orange line is the humidity, the ground humidity of our plant. And, okay, in this day, it took a lot to record this video because
Yeah, a few drops there, yeah.
I don't know if you can hear it.
But it's been raining in Madrid every single day until yesterday, so we thought we wouldn't have this video ready by today, but...
Yeah, we didn't bring our plant. Maybe next time you
Yeah, we can.
the plant.
Yeah, it's warmer here, so maybe it needs more water.
It took like 30 hours of video. This
Days.
thing, yes, really. Okay. So finally, okay, we have a lot of sensors in the market. We have our ground humidity, but environment humidity sensor. We have distance sensor of this one is distance with infrared, and the screeners, and this is quality, air quality, movement. This thing that I don't know how to speed, wind sensor, I don't know, okay.
Wind speed sensor.
Multi sensor. You have a lot of them. They are very cheap. So do your project, and if you need some inspiration of documentation, we have a lot of magazines, web with a lot of projects. People publish their projects in this website. There are a lot. So
that's all. I mean, we went through some of the topics quite fast because there's a lot, to do when you want to turn on a light or water a plant. But if you have any, questions or want further information or, ideas for projects, we'll be happy to help. So.
Okay. you have any question?
Yeah.
Yes, we have our code in